Welcome back, everyone, to part 2 of the solutions for the k-means clustering exercise. Let's head back to the notebook where we left off last time. Okay, here we are in the notebook where we left off last time, and really what we're dealing with here is data preparation. And a big part of that is dealing with the missing data. Keep in mind, k-means clustering is using distance metrics, and you're going to need two specific points in order to actually calculate a distance. You can't calculate the distance from one point to not a number. So let's go ahead and just create a report of the numbers of missing elements per column. This is really easy to do. We've done it a bunch of times before. You simply say df is null. Recall, that's going to check whether or not something is null. And then we can sum these up because it's going to treat every instance of true as 1 and every instance of false as 0. So when we run this, we get to see how many points we're actually missing. So out of around a little over 200 countries, it looks like we're doing okay. Some places we're missing around 10%, but other places just a few items. So let's begin by trying to understand what countries have NaN, or not a number, for some of the higher missing points. So it looks like agriculture, for instance, is missing quite a few points, but you can also see things like industry and service are kind of the same deal. So let's explore these as well. So the next task is what countries have null for agriculture. The way to do this is we say df agriculture, and then we simply pass is null here. Run that, and I can see the countries if I only want the country itself, not the rest of the columns. I run this, and I can see what we have here. Now, this is where you may need to actually open up Google Maps or open up your atlas and check what is actually the main aspects of a lot of these countries. For the majority of these countries, you'll notice that a lot of them are islands, and some of them are not islands. Obviously, Western Sahara is not an island, but you can see here that many of these are kind of just these tiny islands where it would never make sense to have any sort of agriculture. So in that case, it makes sense that agriculture is just not a number because there's probably no measurement for it. So what we're going to do here is we're going to operate under the assumption that if the actual country has not a number for agriculture, then it's not significant enough for it to be recorded, so we're just going to set it to 0. So again, what we're going to do here is the following. We're going to say df, where df of agriculture dot is null, and that's going to get all those rows, and we're going to set that equal to df, where df of agriculture is null. So if I were just to run this, nothing would actually change, but I'm going to call fill NA as 0 here. So what is this actually doing? All I'm doing here is I'm grabbing only the instances where the agriculture column value is missing or is null. I'm going to fill in those values for the agriculture column as NA is equal to 0, so those are filled into 0, and then I'm going to do that reassignment just on the agriculture column for where there's null. So if you run this, and then you try running the code that we just ran here above, so I'm going to check again what countries are missing agriculture. So we're going to come back here and place the following. You'll notice there's no more countries missing agriculture. Perfect. That's pretty much exactly what we wanted. So now let's go ahead and check to see what is still missing by counting number of missing elements per feature. Something you should also note is that if you were to take a look at the other missing values, it's because they're actually so small that they were probably also missing, if we scroll back up here, industry and service. So agriculture, industry, and service, those are just measurements of essentially what percentage of the economy is agriculture, what is industry, what is service. And you notice these numbers all look extremely similar. So what we went ahead and did there is we filled in all the null values with 0 for where agriculture was null. So it's technically not just affecting the agriculture column, it's affecting everything, which is why if we were to check to see what's missing now, df is null sum, and you run that, you'll notice now you actually are no longer missing a lot of industry or services. So was that the right move to make? I would argue that it is, because again, these are all just smaller islands that don't have enough information to really understand what is agriculture, what is industry, and what is service as parts of the economy. That's not to say everything is a tiny island. Obviously, Greenland is an extremely large island, but for the most part, these are also low populations of people in these particular countries. You could be more careful, more specific, but it's kind of just a blanket way to quickly take care of this issue of not understanding or not having values for agriculture, industry, and service for those particular countries. So right off the bat, that took care of a lot of our problems. It looks like we just have a couple of issues here with literacy and climate. So what we're going to do there is we're going to continue on and check how to deal with the missing climate values. So we should note that climate is actually missing for a few countries, but we're not actually missing the region. So region is a literal geographical kind of connection to other countries. So what would make a lot of sense is if we just take the average climate value per region and fill that in for the missing climates. It would make sense that if a country is in Western Europe and we don't know that particular country's climate value, maybe because it's a tiny island off Western Europe, what we could do is just check the climate value for the region of Western Europe, take the average, and then fill that in for the missing climate value. So there's lots of different ways you can do this, and I have a hint on how to do it here. And this Stack Overflow post is basically how you fill in missing values by mean in each group. So what we're going to do is essentially a group by region, calculate the mean climate value per region, and then fill in that missing value. There's actually lots of different ways you can do this. There's a couple different solutions. So we're going to use one of them here. What I'm going to say is the following. I will say df climate is equal to df climate, but I'm going to fill NA. And what am I going to fill for NA? Well, I'm going to group by the region. And then after that, I'm just going to grab the climates column values. And then I'm going to use, and this is the kind of tricky part, is the method transform, which then allows me to pass in a function to actually kind of aggregate this together. So what is this actually doing? It's saying df group by region, only grab the climate column there, and then transform mean, which actually is going to get you the mean climate values per region, and then we're going to do that so I can fill any missing climate values. So go ahead and run that, and then we're going to check again to see if any elements are missing. So I scroll down here. I'm going to say df is null, check the sum, run that, and now you should see that you have a similar issue for literacy percentage, and we'll actually do the same logic for the next task, which is we'll decide literacy percentages and have the average value based again off region. So I can essentially copy this code and simply swap out the column values. So this is going to now be literacy percent. So same here, literacy percent. I'm still going to group by region, but instead of the climate column, I'm going to grab the literacy percent column. So we're going to say literacy space parentheses percent. There we go. And we'll run this same transformation there. And then we're going to check again on the missing values. So df is null.sum. Run that, and we scroll down, and it looks like now we're just missing a few points. All right, now this is where we're going to give you the option. If you want, you can begin doing those same sort of fill NA values based off region, or maybe based off some mean values of population, etc., for things like missing infant mortality or missing net migration, etc. So maybe infant mortality is highly correlated to GDP per capita. So maybe you take the direct connection of GDP per capita and try to fill in that one last missing infant mortality. But overall, we're not actually missing that many points. So what we're going to do is we're just going to drop anything else that's missing by simply saying the following. I'm going to say df is equal to df.drop_NA, because we won't actually be missing too many countries. So if I look at df info right now, I right now have 227 countries. And if I say df is equal to df.drop_NA, and now I check df info, notice I just dropped about 6 countries. Not a huge deal for our clustering analysis, so we'll go ahead and continue. If you want to be a little more careful than that, you can go ahead and start filling this in, but we won't kind of waste time, so to speak, for that, because a lot of those were just really small countries. So moving on to data feature preparation, we have to make sure that we take care of the categorical column values as well as scaling. So if we take a look at what our data frame has right now, it has a bunch of useful features, but for some of them, like region, those are categorical, and for something like country, This is technically not really a feature, it's more of a primary identifier because Afghanistan is not really a feature of this country, it's just its label. So we're going to say df, and we're actually going to redefine this as our x feature set. So I'm going to say x is equal to df, drop the country column along axes is equal to 1. And then my next task is to create those features from the categorical. So we're going to say x is equal to pd get dummies on x. Going to go ahead and run that. And then we're going to scroll down here, and now it's time for scaling. So kind of straightforward, we're going to say from scikit-learn, pre-processing, import standard scalar. Go ahead and run that and say scalar is equal to standard scalar. And we're going to say our scaled version of x is equal to scalar. And I'm going to just fit transform. It's all features. There's no test set. I need to split on that. And now we should have our scaled x data. And there you have it. So it's time to create and fit our k-means model. And what we want you to do is just create a loop and maybe use the elbow method to start looking at interesting k-clusters. As we keep mentioning, there's no 100% correct answer here on how to do this, but we're going to say from scikit-learn.cluster import k-means. And now it's time for the for loop. We'll set our sum of squared distances as an empty list. And then for k in range, maybe something like 2 to 30 would be enough to start seeing any interesting behaviors. Create a new instance of k-means. We have n clusters is equal to k. Say model.fit and have this fit on our scaled x data. And then we're going to append model and recall its inertia for that sum of squared distances. So once you run that, you should, after it's done, be ready to actually plot this out and create this elbow plot. So how do we do that? We're simply saying plt plot, and we said range 2 to 30, and then go ahead and plot those SSD values, run that, and you should see something that looks like this. So a couple of interesting points here. Sometimes it's easier to plot this out using markers and kind of dotted lines. Recall, we can also create a bar chart, to show this difference. So the way I can do that is saying pd series, pass in SSD, calculate the difference there, and then say plot kind is equal to bar, just as we showed in the lectures. Run that and say dot plot. And you should be able to see maybe some interesting behavior. So where are we kind of really doing large jumps in error? So if we take a look at our plot up here, it looks like going from somewhere from around maybe K3 to 4, you're actually reducing not so much in SSD. So that's kind of that big jump happening around here. And maybe the next big jump happens around K is equal to 15. There's no 100% correct answer, but a really useful exercise would be to actually then choose a particular K value that interests you, and then move on to the bonus, model interpretation, which would end up having to decide what correlation or what features correlate highly with this particular K value. So for example, let's imagine that I was interested in K is equal to 3 because of this drop off here. So I would just come over here, I would make a new model with k-means with n clusters equal to 3. So I would say model is equal to k-means, where my number of clusters is set to 3, and I'm going to refit this model. So I'm going to say model fit on scaled x. Okay, so this is a brand new model, and whoops, I said 4, I meant 3. There we go. So this is a brand new model, which means this model also has its labels. So there are the labels, and then what we're going to do is once we have those labels, check out what features are correlated with those. So I can do the following. I can say x, recall x is just those features. I can say x, in this case, with k is equal to 3 cluster labels, and that's going to be equal to model.labels. And then I'm just going to say x correlation values, and then just check out k equal to 3 cluster labels. And if you run that, make sure we spell this correctly. K is equal to 3 cluster with a T. There we go. So if you run that, you should see all the correlations between those cluster labels. Probably want to sort these values. Run that, and if you want, you can also then plot this out as a bar plot. So you can say plot kind is equal to bar, and there you begin to see what is actually associated. So obviously k is equal to 3 clusters. It's perfectly correlative itself, but notice Latin America and the Caribbean is another really strong feature. So is GDP per capita and Western, climate, phones per 1,000. So I would say in general, it looks like the really strong features tend to be these kind of rich Western European GDP climate style countries versus maybe countries that are in the Latin America and Oceania region. Also birth rate is an important factor there. Also death rate was as well. So probably the easiest way to see what's actually happening here is where we move on to the bonus, the geographical model interpretation, where we're actually going to plot these color codes as clusters on a world map. And we're going to do that in part 3. I'll see you there.